Good morning, everyone. So today I will be talking about the gut-liver-bone-marrow crosstalk in chronic liver injury and regeneration. The gut health, importance of gut health is well established in Indian system of medicine very long ago, but recently this also fetch up a lot of attention in terms of particularly in lifestyle related disease. So my outline will be that we will first discuss about the gut-liver axis and briefly describe that how the disruption of that can lead to endotoxin overload, bile acid overload, and the microbial metabolite disturbance. Then I will discuss about the liver regeneration in injury, particularly in context the role of the bone marrow. And finally, I will share some of the recent finding which is linking the gut with the bone marrow health also. So starting with the liver and gut axis, we know that there is an intricate relation between the gut and the liver. So through portal vein, there are various factors which is absorbed through the gut, it reaches to the liver, and through biliary tract, the liver communicate with the gut system. In past few years, there are several studies which suggested the potential link between the gut and liver in terms of the injury and regeneration. There are studies which shows that the uses of probiotics and prebiotics, in one way it inhibits the chemical-induced liver injury, while same time it promotes the liver regeneration. Similarly, the use of oral antibiotics, while inhibit the chemical-induced injury to the liver, it also inhibited the partial hepectomy, induced liver regeneration, while FMT has shown to stop this effect. Similarly, the colon resections also lead to this decrease in the liver regeneration and the germ-free mice. So all this is basically linking that there is some relation between the liver injury, regeneration, and the gut health. This is an interesting finding which suggests that even during the partial hepectomy, there is a fluctuation in the gut microbiota, but whether these are the causes or the consequence is not well established. So starting with that, how the gut impact the liver health. So when there is an increase in endotoxemia, so in one way it helps activate the Kupffer cells, which is helping the priming and initiation of the liver regeneration, but at the same time when this load is very high, it leads to the Kupffer cell activation, hepatocyte necrosis, and also if it is a chronic, leading to the chronic liver injury and as well as the hepatocellular carcinoma. Similarly, for the bile acids, which is an important component secreted by the liver, so when there is a liver injury, you have a bile acid overload. So initially this bile acid overload though contribute in the liver cell proliferation, but when it is high, it can also lead to bile acid toxicity, where the gut plays a major role. So the primary bile acid mainly involved in the toxicity, the secondary bile acid through various way, it try to reduces the bile acid toxicity. Other factors like the gut microbiota also produces various metabolites, which not only involved in the maintenance of the gut health, it also involved in the health of the liver too. So in recent review, it has been well known that during the chronic liver injury, whether this is happening because of the lifestyle or infection, there is a one stage come when there is a increased translocation of the gut bacteria or gut product that is basically acting as a driver of chronic liver injury. So this increased translocation of gut bacteria or bacterial product, whether it is because of the gut-liver barrier dysfunction or the liver clearance. So these two can contribute to the increase in this one. So starting with the first thing, the gut-liver barrier, where the epithelium layer of the gut, particularly it has been well known that the diet impact this. So whenever you have the change in the diet, like Western diet, it leads to the depletion of this mucus layer as well as the dysbiosis, and that basically causes the dysfunction of the first layer of this microbial infection, so intestinal microbial infection, and leading to an increase in the toxemia and inflammation, which make the person more susceptible for the liver disease. And in a way, it has been well known that there are various factors which is basically modulating the liver health. Recently, not, but in 2014, this was the first publication which shows that the liver is also act as a firewall. So the most important finding in this study was that what they shows that whenever you have a gut injury, so there is an increase in the gut, so gut membrane disruption increases the bacterial translocation to the liver. The second thing what they shows that when if you remove the Kupffer cells, so removal of Kupffer cells and the increase in the systemic load of the bacteria is showing a dose-dependent response. The third thing which shows that liver injury increases the gut commensal microbiota in the systemic circulation. So, and most important finding was that this increased gut microbial translocation occurs even in the very early stage of steatosis. So this raises the question that what is basically the cause, whether it is a gut dysbiosis that is leading to this kind of disruption of this liver firewall, or there is a loss of Kupffer cell function. Recently, like particularly if we talk about the non-alcoholic fatty liver disease or its progression towards the inflammation and cirrhosis, it is not known well that what basically trigger the transition from the steatosis to fibrosis and further the cirrhosis. So recently this study shows that in a healthy person, when there is an increased lipid-laden hepatocyte, these are basically erythrocytes by the liver macrophages. However, when there is a prolonged hypernutrition that impair the phagocytic function of the Kupffer cells and leading to the accumulation of this kind of hepatocytes, and that basically lead to their necrosis and beginning of the inflammation and the further progression of liver injury. So this suggests that the link between the gut health and the liver is somehow converging to the macrophage of the liver system. So I'm sharing this ILBS data where we have tried to establish the progressive model of chronic liver injury. So what the one finding which we observe is that during the transition from cirrhosis to a decompensation, there is a decrease in regeneration and there is an increase in hepatocyte injury. The proteomic landscape of this injury suggests that very early during the transition from steatosis to fibrosis and fibrosis to cirrhosis, there is an increase in the neutrophil-mediated inflammation as well as the increased bacterial load to the liver. So this suggests that this factor plays a very important role in transition or further progression of the liver disease. So what happened to the macrophage? So if you see the macrophage population of the liver, it shows a nice correlation with the systemic endotoxemia. So whenever the Kupffer cell number decreases or their phagocytic function decreases, there is an increase in the systemic endotoxemia. The Kupffer cells or the macrophage in the liver in response to injury, there are different type of macrophages come into the picture. Like initially you have the Kupffer cells. Whenever there is an injury to the liver, particularly this experiment has been done in chemical-induced liver injuries where they have shown initially there is a depletion of the Kupffer cells, which is the yolk sac-derived macrophages, and there is a surge of increased monocyte accumulation, which is maximum in case of where there is a maximum injury is peak. When the resolution starts, so these macrophages start differentiating into the monocyte differentiating into the macrophages, which help in the resolution of injury, and simultaneously it also lead to the increase in the Kupffer cell native Kupffer cell population. So that suggests that the bone marrow cells plays an important role in restoring or supplementing the macrophage function of the liver. So then we come to the liver and the bone marrow crosstalk. We have all known that the bone marrow cells plays a very important role. Before the regeneration to start, it helps in clear the damage, provide the parenchymal support for parenchymal and non-parenchymal regeneration. then rescue the host non-parenchymal cell mass as well as remodeling the extracellular matrix. Our group have initially shown with the various publications that there is disruption of bone marrow homeostasis in case of chronic liver injury, which was suggested that in the beginning, that is because of the increased pro-inflammatory cytokine or sympathetic stress. In the beginning, though, there is the marrow is hyperplastic, but in the later stage, it gets exhausted. So the question comes that whether this is a cause or a consequence, it is not known. We also show that mesenchymal stem cells plays an important role in maintaining the NIS component of the hematopoietic stem cells in the marrow, and these mesenchymal stem cells are showing insulin resistance. They are defective in their both glycolysis and oxidative phosphorylation, and they show the functional exhaustion. So to understand that whether the bone marrow is dysfunction is a cause or a consequence, Nidhi has taken this into the animal model, and where she shows that the bone marrow failure precedes regeneration failure and development of decompensated cirrhosis. What she shows that before the regeneration failure occur, there is a loss of bone marrow LT-HSC compartment, which is the most primitive hematopoietic stem cells, and before that, there is a loss of mesenchymal stem cells of the bone marrow. So, she shows that in the kinetic way, with the age, in case of chronic liver injury, there is a significant reduction in the LT-HSC population, and this reduction in the LT-HSC population from the beginning, and there is an increase in LSK population. So, there is an increase in demand adaptive hematopoiesis occurring in the liver.
Anupam used the full form long-term hematopoietic, or what is LSK? People won't understand it. What is?
Okay. So, in case of mice system, it has been well established with the different marker that hematopoietic stem cells, the first most primitive cells is the LT-HSC, which we call as long-term repopulating hematopoietic stem cells. When there is any trigger, it basically differentiate into the short-term hematopoietic stem cells, which we call ST-HSC. And these ST-HSC are highly proliferative and differentiative also, and then they give rise to multiple progenitors or the MMPs. So the combination of all these MMPs, LT-HSC and ST-HSC, they are the bone marrow hematopoietic stem cells and progenitor cells, which we call as the LSK. LSK means lineage negative, c-KIT positive and SK1 positive cells, which represent the hematopoietic stem and progenitor cell population. So as you say, with the chronic liver injury, there is an increase in LSK. So when we dissect this LSK, which we found that there is this increase is mainly because of the expansion of the MPP, and there is a loss of LT-HSC. And this you can also see from this diagram that if we take the ratio of LT-HSC and MPPs, so after 3 weeks of injury, there is a reduction, so that in the LT-HSC MPP, so the balance between the self-renewal and the differentiation is disrupted. We also looked at whether this disruption is because of increased mobilization or because of the loss of the LT-HSC. So we also measure the cell population in the blood as well as in the liver, which goes hand by hand, similar to the bone marrow compartments, which suggests that it is not the increased mobilization. So whatever the reflection you are seeing in the blood or in the liver, it is basically that how the bone marrow is producing the different compartment of the cells. Then when we look for the hematopoiesis, how it is going on, so yes, it is well known, and we also observed this is a myeloid biased. But when we further dissect this myeloid biasness, what we found that up to week 3, both the monocyte as well as neutrophil production is going high. However, after week 3 of the injury, while the monocyte population going down, the neutrophil population is still progressing. Not only that, after 3 weeks of injury, their phagocytic activity is compromised. So the decreased monocyte production and increased neutrophil bias differentiation occurring during the chronic liver injury, and the cells which is produced are functionally defective. Then since we observed the LT-HSC disruption, a loss of LT-HSC, and it is known that the glycolysis is required for the maintenance of self-renewal of the cells. So we found that there is a disruption in the glycolysis, and it is mainly because of the poor glucose uptake in the cells. So similar to the mesenchymal stem cells, hematopoietic stem cells also shows to some extent the insulin resistance and poor glucose uptake. This is also known that when the cells are hematopoietic stem cells start differentiating, they switch their metabolism from the glycolysis to oxidative phosphorylation. And yes, to meet the demand-driven hematopoiesis, there is an increase in the basal oxidative phosphorylation. But this increased demand is in the virtue of this. There is a loss of spare reserve capacity and maximal respiration, so which indicated that could be a mitochondrial dysfunction also occurs during this progression of chronic liver injury in hematopoietic stem cells. And what we found that these change in the metabolic parameter, the energy metabolic parameter, it is not only restricted to their stem cell compartment, but it can progress or it can be propagated to the differentiated cells as well. So whatever happens in the hematopoietic stem cells, if we allow the cells to differentiate in vitro in the normal environment, still these cells shows the same kind of defect like poor glycolysis and the mitochondrial biomass and potential dysfunction. The next, whether this early loss of LT-HSC is a cause of regeneration failure to further proof, what she has done, she tried to restore the hematopoietic LT-HSC population, and what she shows that the syngeneic bone marrow stem cell infusion to the bone marrow induces the repopulation of native LT-HSC. And if you restore the LT-HSC in the bone marrow, it restores the phagocytic number as well as the function of the Kupffer cells. It leads to reduction in the fibrosis. There is an increase in the proliferation. And we also say that with the injury, if we restore the bone marrow, it delayed the progression towards the decompensation in terms of ascites. The third component is that, is there any relation between the gut and the bone marrow in the health? Because we see there is an increased endotoxemia because of which the gut is the primary source for that. So, and there is a change in the metabolic parameter as well as the function of the bone marrow compartment. So is there any relation between the gut and bone marrow? So what the literature says. So in 2015, this study shows that macrobiota from the obese mice regulate the hematopoietic stem cell differentiation by altering the bone marrowness. So what this says that the change in the gut macrobiota basically impact the health of the nastin positive mesenchymal stem cells. So they are making it more towards the adipogenesis differentiation, and the stemness characteristics are lost. They produces less amount of STFN, OPN, VKM, IL-17, which is required for maintaining the hematopoietic stem cell pluripotency. So there is an increase in the myeloid-based differentiation, and there is a loss of lymphoid-based differentiation in this case. Later, there is another paper in 2022 which says that this gut macrobiota is playing a very critical role in terms of stress-induced hematopoiesis. So what this shows that when there is a no gut macrobiota, yes, there is an increase in the LT-HSC population, but the mature population is less. When there is a germ, the gut macrobiota is intact, so that leads to the balance between the self-renewal as well as the differentiation of these cells towards the mature phenotype like myeloid cells or the lymphoid cells. And what this is that the gut macrobiota metabolites like butyrate, which is get depleted when there is a gut dysbiosis. So this butyrate is required to maintain the phagocytic function of the bone marrow macrophages. And this initial phase of hematopoiesis, there is a RBC death also is there. And these dying RBCs basically engulfed by these macrophages, which produces the iron and which is required for the differentiation of this hematopoietic stem cells towards the mature progeny. Later, there are also studies which says that the germ-free mice are basically having a poor innate immune cells in spleen as well as in the liver. And if you restore the gut microbiota, it leaded to the restore the innate immunity against systemic listeriosis. So gut microbiota is also required to maintain the body's capacity to fight the infection. The most important thing that this recently study shows that yes, when there is an increased load of the bacteria in the system, so there is an increased production of the myeloid cells or increased proliferation of the hematopoietic stem cells. In acute phase, they shows that before the MPP start producing, there is expansion of LTHSC, and then it goes to the MPP population. So though this study suggests that though in response to infection, there is an increase in the proliferation and differentiation of the hematopoietic stem cells, but at the same time, there is an increase in ROS stress and in the LTHSC or the hematopoietic stem cell compartment that compromise the functional fitness of the HSC. So that means when there is a chronic injury, there is a loss of LTHSC population and exhaustion of the bone marrow cells. There is recently a study which says that there is a link between IL-1 mediated inflammation and this disruption in the hematopoiesis in response to infection. So altogether, this says that the gut liver, there is an increased burden of gut endotoxemia, the bile acid overload, as well as the change in the microbiota derived the metabolites which disrupted the health of the liver. In the second way, the gut also impacts the health of the bone marrow in terms of their hematopoietic fitness and production of the different type of hematopoietic cells. So, and when there is a poor gut bone marrow function, the loss of liver macrophage system is there. So this macrophage system is required to maintain the systemic endotoxemia. However, when there is a gut dysfunction, it also leads to dysfunction of the hematopoiesis, which further lead to the loss of the liver macrophage system, and there is an increase in the overload of the gut-derived infection molecules in the system, which might be involved in the progression of the chronic liver disease. So the way forward is that will restoring gut health, liver macrophage function in cirrhosis will prevent the loss of LTHSC and hematopoietic dysfunction, prevent regeneration failure and onset of decompensation. So we have initially we got one grant from the CRG where we are trying to look out the gut as a parameter to see that whether it is involved in the hematopoietic dysfunction which we have seen in case of chronic liver injury. Thank you very much for your attention.